Polynomials, add, subtract, multiply, divide. Adding polynomials and brackets. When there's nothing in front of a bracket, there is a hidden positive sign, which means we can drop the bracket and write exactly what we see. It's as if you're distributing the positive sign to each of the terms on the inside, and because it's a positive, nothing on the inside changes. The same can be said for the positive sign that's actually there. What you're really doing is distributing it into the terms inside the bracket. So again, I'm going to write exactly what I see as I expand that bracket. And now I have an expression with no brackets, so I'm going to collect like terms. I'm going to put the x squareds together. I'm going to put the x's together. And finally, the constant terms go together. Please remember that an x squared is different than an x, which is different than an x, say, 7. These are all different terms. So now I'm going to simplify. So 1, remember the hidden 1 out front. 1x squared plus 2x squared is 3x squared. 4x minus 6x is negative 2x. And negative 2 plus 9 is positive 7. So our simplified expression is 3x squared minus 2x plus 7. One more example. Again, there's nothing in front of the bracket, so there's the hidden positive sign, which we will now distribute into the 3 terms inside the bracket. And just like before, nothing changes because you are multiplying through by positive 1. So it becomes negative 4t squared, negative 6t plus 7. The same thing here as before. It's a positive sign that you're distributing. So write exactly what you see. And now you're going to collect like terms. I always forget my equal signs. So put the t squareds together, the t's together, and the constant terms together. Simplify each set and you get negative 7t squared minus 7t minus 1. And there you have it, 2 examples of adding polynomials. I'll just throw in my equal signs to make it look proper. And now we'll subtract polynomials from each other. The same system as before. If there's nothing outside of a bracket, there's the hidden positive sign, which you distribute into the bracket. And by distributing the positive sign, nothing changes. So you can simply write what you see. Here's the difference. We now have a negative sign in front of the second bracket, which we need to distribute inwards to each of the terms inside. So it becomes negative 7x squared, negative 4xy, and positive 2. It's as if you're multiplying through by negative 1. Same process as before. Collect like terms. Put the x squareds together. Put the xy's together. And put your constant terms together. These pair up nicely. They don't always, but in these examples they are. So 6 minus 7 becomes negative 1x squared. Negative xy, negative 4xy becomes negative 5 of the xy's. And 4 plus 2 is 6. Another example, same thing here. There's nothing out front of the first bracket, and there's a negative sign in front of the second. So I'm going to distribute the hidden positive sign, distribute the negative, and each of the signs now inside of that bracket will change. So instead of a negative, it's a positive, and the positive 8 becomes a negative 8. Again, collect like terms. Put the d's together, the d squareds together, and the numbers together. Negative 4 plus 5 becomes 1d squared, 4d plus 1. And there we go, 2 examples of subtracting polynomials. And now on to multiplying. When you multiply polynomials, you take the constant terms and multiply those first. So 2 times 7 is 14. The exponent multiplication follows the exponent rule. So you have x squared, and there's a hidden 1 above that x. And when you multiply variables with exponents, you are adding the exponents together. So it becomes 2 plus 1. So the final result will be 14x cubed. Another example, a little more complicated, but again, the same structure. Take the numbers and multiply those through. Negative 4 times 3 is negative 12. And now we're going to do our variables. We have an a squared and an a1. So 2 plus 1 becomes a3. We have a b1 and a b3. 1 plus 3 is 4. So our final result will be 12a cubed b to the 4. Multiplying polynomials. Dividing is the opposite operation from multiplying. Same starting point. We're going to take our 2 numbers, 2 coefficients, and we'll divide those first. So 20 divided by negative 5 is negative 4. And then remembering our exponent rules, that is going to become x3 minus 2. Remember, when you divide exponents, you are subtracting. So that becomes x to the 1. We don't write the hidden 1, so it's simply x. Dealing with the y's now, it becomes y4 minus 2, which is y squared. So the final result, negative 4x y squared. Example number 2. We have negative 4 divided by 1. Remember, there's a hidden 1 out front of every variable if there's no other coefficient. Negative 4 divided by 1 is still negative 4. The a's are a7 minus 4. There's no b, so it's simply b to the 8. And c would be 3 minus 2. So the final result, 7 minus 4 is 3. B has nothing to divide by, so it's left alone. And c becomes c to the 1, or c. And that is division. Expand and simplify. I have 2 examples. My first example is broken up into 2 parts. You can see that it's separated by a negative sign. Negative signs and positive signs can separate out an expression into different parts. So in this expression, we have two parts here separated by a negative sign. In the first part, to expand this, I will take the term 3x and I will multiply it into the bracket, and that will result in 3x squared minus 6x. Remembering there's a hidden 1 on top of these x's, and when you multiply, you add those two together, so it becomes x squared. Now, in the second half of the question, I've got a negative 2x. I'm going to take all of that and distribute in to my second bracket. So that will give me negative 4x squared minus 10x. I'm now going to collect like terms, just as I have in the other example. So I'll put the x squareds together and the x's together. Simplify those. 3 minus 4 is negative 1 x squared. Negative 6 minus 10 is negative 16x. I wrote the negative 1 here just to say that that's bad math form. For sure, 3 minus 4 is negative 1, but we don't need to put the negative 1 out front. We can simply say exactly the same thing by saying negative x squared. There's just one of them. And then minus 16x. So be a little bit careful with form here. While that is mathematically correct, jotting down the negative 1 is, again, bad form. On to the second example. I have a few more interesting exponents in this example, but it's the same process. I have two different sections. The first section, the second, separated by that plus sign. I'll take my term outside the bracket and expand the bracket, distributing. I'll also then take the g squared along with its sign and distribute in to the bracket. Expand, distribute. So here we go. I'm going to do it all in one line. Negative 5g4, 2g2. Again, take the numbers, multiply those out first. Negative 10. Add the exponents together. 4 plus 2 is 6. Negative 5 times 7 is negative 35. And g4. In the second half now, take the g2 and multiply. That becomes plus 6g6. And into my second term becomes negative 4g4. I'm going to collect like terms, putting the g6's together and the g4's together. And that will give me negative 4g6, negative 39g4. And there's two examples of expand and simplify. And now a challenge question. This challenge question is in three parts, separated by two signs, by a plus sign and a negative sign. So in each one of these parts, you take the term outside the bracket and expand. Make sure that you collect the sign when you expand into the bracket. And now we're going to get 4a squared plus 12ab plus 10ab. You might instinctively write 10ba, but we always write our variables in alphabetical form. Then it becomes negative 5b squared, negative 6a, and positive 6b. I'm going to collect like terms, And looking at it, the only two terms that are similar are 12ab and 10ab. So on my next line, I'm going to simplify 22ab, and then everything else is a singleton. And you can write what you see. You can certainly write this in a different order and put the b squared at the very end. So it would look like this. So 4a squared, and I'm going to put our negative 5b squared at the end. And so now I'm going to do minus 6a plus 22ab plus 6b. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I've got them all. And there you go. Our challenge question solved. Thanks for listening.